3, problem 12 reads, a rookie quarterback throws a football with an initial upward velocity component of 12 meters per second and a horizontal velocity component of 20 meters per second. Ignore air resistance. So, A, how much time is required for the football to reach the highest point of the trajectory? So that one's pretty easy. So just drew our components here, and the arc the football will take, h being the height at the peak, and r being the overall range or distance. G is 9.81 because, well, we can assume we're on Earth. So with the equations we derived in class, the time at the peak is equal to our y component of the velocity divided by g, so that's 12 over 9.1. So our time at the peak is 1.22 seconds. B, how high is this point? So h being the height at this highest point is our, with equations derived in class, is our Vy squared over 2g, so that's 12 squared over 2 times 9.81, which gives us a final height of 34 meters. And then C, how much time after it is thrown is required for the football to return to its original level? How much time after it is thrown is required for the football to return to its original level, and how does this compare to the time calculated in part A? Well, since there's no air resistance, our acceleration downwards is going to be constant, so to get to the origin level is just going to take twice as long as it took to get to the peak. So our time 2, which will be our time here, is equal to 2 times t peak, so that's 2 times 1.22, and you get 2.45. Reason slightly off is just rounding. I just doubled the answer I got here and then rounded afterwards. So that's why it's different. But 2.44 works if you go based off of your original. And then part D, how far is the football traveled horizontally during this time? Again, an equation we calculated in class is going, or actually, no, so the distance equals velocity times time. We know the x component of our velocity is 20 meters per second, and the time it travels to get to this point is going to be our t2 that we calculated. So we have 20 times 2.45, and we'll get a final range of 49 meters. And then part E is to graph the x of t graph, the y versus t graph, the vx of t graph, and the vy of t graph. So our x of t graph, since our velocity is constant, we'll have a nice linear slope here. As time moves on, it'll move a proportional distance away. Our y of t graph will really just be the arc that the football makes over this course of time. So 34 meters, it's at the height, and that's at 1.22 seconds, 2.45 to return to the same height. Now our velocity x component times to time graph, since we have a constant velocity, we have a zero slope. There's no acceleration, hence the horizontal line. Our Vy of t graph is slightly different since our acceleration is negative. You have a negative linear slope, and so we move from initial velocity of 12 going down at a constant rate. You can also take the derivative of your x of t graph will give you your vx of t, and derivative of your y of t graph will give you your vy of